Hi everyone, welcome back to my channel Leela WebDev. So in this video we will try to learn about the new concept what is called as an concurrency and parallelism. So let's try to go to the top. Yeah. So concurrency versus parallelism. How computer juggles the multiple tasks. So this is our very much important. This is a super cool concept which you need to understand. Now you need in this video we will try to understand how computer handles the multiple tasks simultaneously. So that means, so if you are having a multiple tasks, how the computer handles a multiple task so that the multiple tasks are executed simultaneously. Today we will dive into the fascinating world of both the concepts terms, that is nothing but concurrency and parallelism. So these are the two fundamental concepts that make our modern computing experience possible. So that means we'll try to understand the difference between the two concepts, that is nothing but concurrency and also the parallelism. So these are the two things which you need to understand. So let's try to see our agenda. So what is our video? This video agenda is this one agenda is our journey through the computing multitasking. First, we'll try to understand how the single task computing will be performed in our olden days. How in the olden days the computing will be there and its limitations, and we'll try to see the same single core in the modern thing. How the concurrency creates the illusion of multitasking, and if you are having more than one core, two core systems which you are trying to have right now, so how we can achieve the parallelism and its advantages and the real world impact, how these two concepts like concurrency and parallelism having in your computing makes the everyday computing easy. So let's try to see these four concepts in this video. So now let's first understand about the old days of computing. So decades ago, when the computers are in the getting started, so that means the computers when we are getting at the starting phase, so computers used to have only single CPU core. So that means it can only handle one process at a time. Process means here you need to understand it is just simply a program or an app running in your computer. So you can say it as a web browser or a game. So that is not that's a simple thing, or you opening an email or anything. So now here in our olden days, we are having only single CPU core, and that CPU core doesn't have a concept of context switching and all those things. So if one process has been came in, so that one process needs to execute. When the process is completed, then another process kicks in. So that means if you want to open another program means first of all you need to close the current working process before starting the next one. So that means imagine that you have opened your music player or watching any movie or something like that. Then you have got an email in such a way that you need to open the email. So then what you need to do, you need to close that music player and you need to check that email. So that means one process only it will work at a time. So there is no concept of context switching. So this is frustrating at the in the olden days. Now let's try to see in the modern days with only single core. So the limitations of the single tasking is, so there is no concurrency. So that means the single core cannot able to take up the multiple process at a time. So it cannot take the multiple tasks at once. And also there is no parallelism concept. Only one operation could be performed at a given moment. And also user face constant waiting and interruptions. Why? Because it needs to switch between the tasks. This single task approach severely limited the productivity and the overall computing experience. So let's try to see about the modern systems, how we work with one core CPU. So right now we are having more than one core CPU, like 12 core, 20 core CPUs also we are having. So just I want to tell you how modern systems work with one core CPU. So now today, even with just one CPU core, we can able to handle many processes. This is called as an concurrency. Why? Because this is because of the concurrency. So the operating system, so whatever the operating system you are having, it uses a dispatcher to manage the process. I already told you about the dispatcher. So all the process whichever will be there, it will be in the ready state at the starting. The dispatcher, it will be managed to cycle through the different states like ready, running and the sleep. So the dispatcher will be responsible. So now let's try to see. So now how the single core can able to handle the multiple processes. First one, multiple apps or process will be in the ready state waiting for the CPU time, and the dispatcher selects one process and moves it into the running state. And what it will be able to do, whenever it moves into the running state, the CPU scheduler will schedule the time, that how much time the process needs to be executed in the CPU. That is called as a quantum or the time slice. And when this process the time scheduling is finished, it means the process will be moved again into the ready state and another process will be picked up. So like this, the CPU switches to another process in such a way that we can able to see that multiple tasks are able to apply. So this is called as an illusion of multitasking. So here what is trying to do is, it is not, the CPU core is not performing the multitasking. it is switching the tasks between the tasks so that you can able to understand that it is happening multitasking. The switch happens so quickly that sometimes in microseconds that it feels that like all your apps are running simultaneously. But you need to understand one thing: with one CPU core, only one process is actually running at any given moment. The CPU is just switching between them incredibly fast. So this is what called as an concurrency, the ability to juggle the multiple tasks by rapidly switching between them. So now let's try to understand about the two core machine. So with two CPU cores, everything changes. Now you can run two processes at the same time. So this is where parallelism comes in. So now you combine the concurrency and the parallelism, so you can able to get the fast computing thing. So each core has its own program counter. I already told you, right? Each one core has its own program counter. Now we are having two core CPU means, so we will be having two program counters, and each core has its own program counter which keeps tracks of the instructions it is executing. So now one core works with one task and another core works on the second task simultaneously. So now the parallelism is achieved. Now the power of parallel processing, let's try to see. Single core scenario means, let's say that with a simple example. So let's say that I will try to give you a simple example for this one. So let's say that you are having here, you are having a single core. Okay, so this is the CPU core. So single core. So this is the core you are having, and here you are having a process queue which is in the ready state, and here you will be having one process and you are having another process. So each process will take 10 seconds of time. So this one to complete 10 seconds, and this one to complete it will take 10 seconds of time. And here you will be having the sleep thing. So if you want the process waiting for any blocking or something like that, means it will go into the sleep state. So now the CPU core only one. So the one process through the dispatcher, it goes into here and it starts the executing. Okay, here done state will be there. So it starts the executing, and again it will be moved to the ready state. So again this another process will take here and it will try to execute, and after some time again this one will be moved to the set. So this type of switching will happen in such a way that, so after some time these two process will take nearly 20 seconds to complete, right? Why? Because we are having single core. So totally the process 1 will take 10 seconds and the process 2 will take seconds. Totally in 20 seconds the two process will be completed. So this is what will happen with the single core CPU. Okay, so let's try to see this one. So let's try to keep the full screen. Yeah, so now two 10-second tasks must share the CPU. Total completion time is approximately 20 seconds. It will be more than 20 seconds. Why? Because the context switching also will happen, right? So you cannot say that it exactly 20 seconds it will take. More than 20 seconds it will take. Why? Because it needs to switch from ready state to running state like that. So tasks run concurrently but not in parallel. So here the tasks are running concurrently but not in parallel. Now whereas if you try to check the dual core scenario, two 10-second tasks each get their own core. Total completion time is 10 seconds. Tasks runs truly in parallel. So here that is twice as fast plus a tiny bit of extra time for switching, just like a few milliseconds. So that means if you are having two cores, so what will happen? So let's try to have the two simple things. And here I am having again the process P1 and also the P2. Each one takes 10 seconds time to complete it. And here this time you are having the two cores. Okay, so the P1 goes into here and the P2 goes into here. So P1 and P2. So both the two process will try to run it parallelly. So that means, so again it will come to the ready state, and again the core will be so ideal. So again like this, the context switching will be going on. So now approximately within 10 seconds the two process will be completed. So that means twice as fast as when you are trying to do with the single core. Okay, so plus 10 seconds it will be there. Why? Because of the context switching to the ready state to the running state like that. So more than 10 seconds it will take, and here also more than 20 seconds it will take. This is normal. This is the normal process which you can able to see. So now here, so now you are able to understand this concept. So let's try to, so now you understood about this power of parallel processing. So try to understand the difference between concurrency versus parallelism. The key difference. So concurrency means about managing the multiple tasks, works even on the single core machine, and it will create the illusion of the simultaneous execution. Tasks are interleaved but not truly simultaneous. What about parallelism then? About executing multiple tasks at the same time, requires multiple CPU cores, achieves true simultaneous execution, tasks run independently on separate cores. So that is the main thing. So you can think of something like single chef working on a like a chef. Concurrency means you are having a single chef, but he is working on the multiple dishes on the kitchen, cooking a little bit of each dish at each time. Whereas parallelism means having two chefs each cooking a complete dish at the same time. So this is what the difference between concurrency and also parallelism. So now you can able to visualize the difference. Concurrency is about dealing with the multiple tasks, while parallelism about doing multiple tasks at once. So why this matter? The user experience. Concurrency and parallelism are what make our device feel so fast and responsive today. Whether you are streaming a video, chatting with friends, or editing a document, your computer is using these concepts to keep everything running smoothly. More CPU cores means more parallelism, which translates to faster performance and lesser waiting. So that is the thing. So as processors evolved from single core to multi-core designs, both concurrency and parallelism capabilities are also have dramatically improved, enabling the rich computing experience we enjoy today. So real world applications like you can able to see video editing, multi-cores can process different video frames simultaneously, dramatically reducing the rendering times. And gaming and web servers, it can handle thousands of concurrent connections by distributing requests across the multiple cores. So mobile devices and all those things you can able to see. The future many core computing. The trend is clear. Processors are incorporating more and more cores. Some high-end CPUs now feature 16, 32 or even 64 cores also. This enables massive parallelism where dozens or hundreds of tasks can execute simultaneously, revolutionizing fields like AI, scientific computing and real-time data processing. So that is what I want to explain you. So concurrency is about managing multiple tasks through rapid switching. Even single core systems can achieve concurrency by quickly alternating between processes. Parallelism is about executing multiple tasks simultaneously. This requires multiple CPU cores with each core handling its own process. Modern computing relies on both concepts. Together they enable the responsiveness, multitasking experience we expect from our devices. So that's it. So that's it guys about this one. So thank you for watching. Now you know how computers went from handling one task at a time to juggling tons of processes with concurrency and parallelism. So if you found this helpful, give it a thumbs up and hit that subscribe button and let me know in the comments what technical topics you want to learn about next. See you in the next video. Thank you guys.